Hey guys, so today I'll be helping you genius up with mathematical literacy. So we'll be working on this Feb 2018 question paper, specifically on question 5, which is on data handling, right? So I find mathematical literacy really interesting because it's one of those subjects whereby they ask you real life things or you're doing practical things, right? So let's work on this question over here, which is on data handling. It's a Feb 2018 question paper. So let's just read the question. Let's just analyze the data that they gave us and highlight important things in this data. So the first thing they say, uh, the two box and whisker plots below represent the percentage marks achieved by two grade 12 classes. So these two box and whiskers over here, they represent the grade 12 marks, right, for two classes, which is class A and class B, right? And then they say each class consists of 26 learners. This is very key to know that in each class, that means we have 26 marks, right? We have 26 learners, meaning that the numbers are also 26. And then we have the two box and whiskers. It's very key to understand how to analyze a box and whisker and to know what a box and whisker means, right? So let's just talk through this box and whiskers a bit, right? So we know that the first whisker over here, where it ends, that's where we get our minimum mark, meaning that the student who got the lowest mark in either of the classes, it's represented by this whisker over here, where it ends, right? So we can see that in class B, the student who got the lowest mark got 10, right? Got 10, right? 10. Forgive my line over there, but it's 10, right? And for class A, the student who got the lowest mark got somewhere in between of 50 and 60, which is 55, right? If it's in the middle of the street, it's 55 for class A. And but we're not really sure. It's somewhere between, but we're not really sure because sometimes these things are not thrown to scale. But we can assume that it's 55, right? I'm not saying it's 55, but I'm just saying we can assume it is 55 because it's in between 50 and 60. But it can be any number. It can be 54. It can be 56. But we just have an idea that the lowest mark was between 50 and 60. And this end, this end represents the student who got the highest mark in class, right? Meaning that in class B, the student who got the highest mark got 100%, right? I'm sure it's going to be you getting 100% on that final, but here class B, the student who got the highest mark got 100%, and in class A, the student who got the highest mark got 90%, right? Got 90%. So we've analyzed our box and whisker. Another key thing to note is in the box here, we also get some key information, right? We said this one represents the minimum, this one represents the maximum mark. So I'm just gonna do it for class B, but for both classes, the whiskers represent the lowest and the highest mark. And let's go to let me just erase this thing, erase this thing. And this first line on the box here and the one here, this first line, they represent what we call quartile 1, or also referred to as the lower quartile, right? So it's quartile 1 or a lower quartile, right? So let's just indicate that, okay, this one over here represents quartile 1. So for both box and whiskers, this lower end of the box, it represents quartile 1, and this one over here represents the median, right? The median number, the median mark, meaning the mark that it's in the middle, right? Also referred to as Q2. So I need you to know that the middle line on the box, the middle line, it represents the median, also known as Q2, right? This one over here, it represents the middle mark or the median, also known as Q2. And this last line over here, it represents quartile 3, which is also referred to as the upper quartile, right? quartile 3, also referred to as the upper quartile, right? So I've analyzed our box whisker actually, right? So we said this first part represents the minimum mark, this one quartile 1, this middle line represents quartile 2, and then the last line on the box represents quartile 3, also known as the upper quartile, and this last line over here, it represents the maximum mark. Same thing with class A, right? So that's our box and whisker. And then they say the percentage mark for class A arranged in order. So this is very key. They've already arranged these marks in order, so you don't need to go back and rearrange this data. It's already arranged for you in order. So if you want to calculate your median, your quartile 1, your upper quartile, also known as quartile 3, you can just calculate it because this data is already arranged for you in order, in ascending order. It's given below, right? So they gave you all the marks here, and then F and H. So you have two marks which are represented using alphabets, meaning that they didn't give you the actual mark. They just say, okay, here at F, there's a mark that's supposed to go there, but we didn't give you that mark, right? And then they say, no, F is the lowest percentage mark. Remember, I said these numbers over here, these marks, they've already been arranged in ascending order from the smallest to the highest. So meaning that F, the first mark, will be the lowest mark in class A, right? The lowest mark in class A. Remember here I said this whisker over here, this line over here represents the lowest mark. And then I said it's between 50 and 60. It can be any number, 55, 54, and whatever it is, right? But that's the lowest. So here the F represents the lowest mark, right? The F here, sorry about that. And then they say H is a percentage mark between 75 and 80. So H is between 75 and 80. You can see that from the data because I said this data has already been rearranged. Let's go and answer our question 1, right? Since we've already analyzed the data given to us, right? So let's go and answer our question 1. So our question 5.1.1, they say which one of the following terms best describes the data above? So they say, is it categorical, is it numerical, or is it qualitative, right? So let me just point out something. Let me just explain these types of data, and then we'll decide which one is correct after. So let me just point this thing out, right? Categorical and qualitative data is usually the same thing, right? Because categorical is whereby we categorize the data, right, based on a certain criteria. Let's say, for example, we say red, blue, and green, right? So we categorize the data based on the color. Let's say, for example, we're talking about cars, right? And then we say we're categorizing them based on color, whether they red, they blue, or they green. So we can say, okay, red cars, they 5, and then blue cars are this much, the green cars are this much. That's categorical because we're categorizing the data, right? The data is into categories, which in this case will be the colors, which is the red, the blue, and the green. Same thing as qualitative. Qualitative, it basically means the data is in weights, right? Such as red, blue, and green. Those are weights, right? You can say, okay, we have 5 blue cars. That's how we categorizing the data, and it's in its qualitative form, right? But when we come to numerical, numerical, we talk about numbers. This data is in numbers, right? 58%, 60%, 62%, and stuff like that, right? So this data is in numbers. So wherever you just see plenty of numbers, you know that this data is numerical, right? If it was categorical or qualitative, categorical, they were gonna be like categories saying, okay, blue, red, and green, and then we categorize the data based on that. Okay, we have like 3 green cars, 5 blue cars, and stuff like that. Or for example, we categorize it based on gender. We say blue and say blue and not blue, we say maybe boys and girls, right? And say we have this much girls and this much boys. That's categorical, right? And qualitative, it has to do with weights. So the only option left is numerical, meaning that the answer here will be numerical, right? This data is numerical, it's in numbers, right? Numerical. And we can move to 5.1.2. So they say determine the percentage. I like to highlight the keywords in the questions, right? Determine the percentage. So the answer we're looking for is in percentage form. Percentage of the data values that lie between the upper and the lower quartile, right? So we're looking for the percentage of data values that lie between the upper and the lower quartile. And one thing to note here is they didn't tell you whether for class A or for class B. And I'm going to show you why, right? Because this thing is standard. Let me just go back up. So they gave us the two box and whiskers. Let me just erase this things over here, right? Let me just erase, right? So just remember this, that here we're talking about, oh, let me just say, so just remember that the first line over here is quartile 1, this one is quartile 2, and this one is quartile 3. And I said quartile 3, which is here, is the same as the upper quartile, and this one is the lower quartile. So question 5.1.2, we're looking for the percentage of data values that lie between the upper, which is here, the upper, and the lower quartile, meaning we're looking for the data values that lie between this area over here, right? They didn't tell us for which class. Why? Because this thing is standard. So one thing is that the quartiles, they divide our data set regardless of which data we're analyzing or which data we're representing. Quartiles, they divide our data set into 25%, right? Into sections of 25%. So this one is, let's say, is the minimum here, and then we have quartile 1 here, and then we have quartile 2 here, and then quartile 3, and then the max, right? This is the max. So quartiles, they divide our data into 25%, right? Meaning that divide our data into 20 sections of 25%, 25%. What do I mean by that? I'm just saying, so meaning all the data values that will lie between the minimum and the lower quartile, which is the first quartile, are 25% of the data set, right? And all the data sets that are going to lie between quartile 1 and the median, which is also known as the quartile 2, is 25%, right? Same thing with all the data that lie between quartile 2 and quartile 3 will be 25%. All the data values that lie between this are 25%, and that lie between quartile 3 and quartile, and the maximum, I mean, will be 25%. So quartiles divide our data into sections of 25%, right? So if you add all this 25%, you get 100%. So 25 plus 25 plus 25 plus 25 is 25, is 100%, which is our entire set of data values, right? So quartiles, remember that quartiles divide our data values into 25%. You can just, if you ask the question like this, they say determine the percentage values of percentage of data values that lie between the upper and the lower quartile. You can just draw this diagram over here and say minimum quartile 1, quartile 2, quartile 3, and max, and then just say 25%, 25, 25, 25 in each. And if you add all the 25s, they need to give you 100%, right? But they said they want the percentage of database that lie between the upper and the lower quartile. Remember, I said the upper quartile is quartile 3, and the lower quartile is quartile 1. So quartile 3 to quartile 1. So we're looking for the percentage of the data values that lie between quartile 3 and quartile 1, the upper quartile and the lower quartile. And this is made of 25 plus this 25, giving you 50%. So your answer for 5.1.2 will be 50%. The percentage of data values that lie between the upper and the lower quartile is 50%, right? Because I said quartiles divide your data into sections of 25%. So if from mean to quartile 1 is 25%, from quartile 1 to quartile 2 is 25%, quartile 2 to quartile 3 25%, quartile 3 to maximum is 25%. If we're looking for the percentage of database that lie between quartile 1 and quartile 3, we'll take all these two percentages and add them. Why? Because from quartile 1 to quartile 2 we have 25% of data values, and from quartile 2 to quartile 3 we have another 25% of data values. If you add the both, you get 50%. So the percentage of data values that lie between the upper and lower quartile is 50%. So I'm quickly going to write the answers over here. Let me just write them real quick. So the answer for 5.1.1 is numerical, and the answer for 5.1.2 is 50%, and I just explained why. And let's move to 5.1.3. So with 5.1.3, they say the range of class A is 34%. So they gave you the range. They say range is 34. And remember, what's the range? The range, let me write here and say, so now we're dealing with 5.1.3, right? And the range, what's the range? So the range is equal to the maximum value minus the minimum value. So this is what makes up the range, right? The range is equal to the maximum value minus the minimum value. So they gave you the range here. They say the range is 34. So you already have the range. You can write it down and say, okay, my range is 24, which is equal to. Now they say calculate the value of f. See what I just did here. When they said the range, I quickly wrote down the formula for the range, and the question says calculate. The question says you must calculate the value of f, right? And if you check this out, f is actually the minimum amount over here, the minimum value. Remember, they say f is the lowest percentage mark, right? F is the lowest percentage mark. So x is actually this minimum value over here. It's this minimum value over here. Now we can use our formula to calculate that value of f, right? We can say, okay, since we have the range here, the maximum value is 90. So you say, okay, my maximum value is 90. You write it down and say minus the minimum. So they didn't give us the minimum, but they gave us f. So we put f, right? And now we try to solve for this f. To solve for this x is simple. What you do is take this f to the other side of the equal sign. And when you do that, it changes the sign from negative to positive. So when it comes this side, it's going to be positive f rather than negative f, because it went to the other side of the equal sign. Know that when you take numbers or variables to the other side of the equal sign, they change the sign to the opposite sign, right? And this side you are left with 90. Check this thing out. Even the 34, I'm going to take it to the other side, take it to the right hand side, and when I do that, it's going to change the sign from positive. This side was positive. You see there's no sign. When there's no sign on the number or a variable, it means it's positive. So since it's positive and then it's going to the other side of the equal sign, it's going to be negative 34, right? And then you simply say, okay, f is equal to 90 minus 34. Let me just take my calculator real quick. 90 minus 34, and then that's 56. So your value of f is 56. You already know that your value of f is 56. And then you can just go to your table and fill it in case you might need to use it later. And say, okay, 56. So this is the value of f. F is 56, right? And let's move to the next question. So the next question, they say calculate the median percentage mark for the class. So the median percentage mark for class A. Check this one out for class A. Even here, it was key to know that they speaking about class A, and then they use this formula over here to calculate F, because this data over here is already arranged and it's for class A. So here they say calculate the median percentage for class A. Median percentage for class A, right? Median percentage for class A. What is the median? The median is the middle number. The middle number is the median. And if you look at this box and whisker over here, it tells us that, okay, this median number sorry for that, this median number is somewhere here close to 70, right, on the left hand side of 70, meaning that it can be 67, it can be a 68, somewhere there, because it's close to 70, but we don't know the actual number. We can't rely on this box and whisker because it's not exactly on the number. So now we need to go and calculate this median number for class A. Remember, we're talking about class A using this data over here. And how do we do that, right? How do we do that? So here you have to understand what's the median. The median is the middle number, the number in the middle, right? So you just have to count from either side to the middle number, right? Sometimes you, like if your data values is even, meaning that just like in this case you have 26 values, you can't find the exact middle number, right? There's no middle number, but there are two, so you'll take the two middle numbers, and then what you do, you divide it by 2. So I just erased my numbers over here so that I can be able to calculate this median number, which is the middle number, right? And I said if you don't get any middle number, you take the two middle numbers and then you divide them by 2. Let me show you what I mean, right? So I'm gonna start this side, cancel one this side, cancel another one this side, cancel one this side, cancel another one this side, 1 1 1 1 1 1 1 1 1 1 1 1. So I'm gonna do this until I'm left with only one number in the middle or two numbers, right? So let me see how much I've cancelled. 1 2 3 4 5 6 7 8 from the top, and 1 2 3 4 5 6 7 8 from the bottom, right? I cancel another one from the top, and I cancel another one from this side, one from the top, one this side, one from the top, one this side, one from the top, one this side. So check this out, I'm only left with two numbers. If I can't, so I'm supposed to find the middle number, and I've cancelled almost equal numbers from either side. Let me check. 1 2 3 4 5 6 7 8 9 10 11 12. So I've cancelled 12 numbers from the top, and I've cancelled 1 2 3 4 5 6 7 8 9 10 11 12 numbers again from the bottom, right? So if I cancel one here, I'll need to cancel another one, and then I won't be left with any number in the middle. So I have two middle numbers here. You see what I was talking about? I have two middle numbers. So another thing you can do here, you can use your fingers and say 1 2 3 4 5 6 7 until you left with like two numbers in the middle or one number. If you left with one number, you're lucky. What you do, you take that number, it's your median. But if you left with two numbers, then you need to take the two numbers, which in this case 67 and 69, divide them by 2, and that's your median. So in this case, when you talk about so we 5.1 point, so we're doing 5.1.4, right? So 5.1.4, our median our median will be equals to, it's 67 plus 69. Remember, we left with two numbers in the middle, which are the two middle numbers. We divide them by 2, and then your answer will be 68. So this 68 over here is your median. You only do this if you left with two numbers in the middle. But if you left with one number in the middle, let's say you had like 27 data set. By doing that, cancelling numbers on either side, equal numbers, when you get that, you'll be left with one number in the middle, which is your median, right? But if you left with two numbers like this, which are your two middle numbers, you take them, you divide by 2, and then that's your median. And then let's talk about 5.1.5. So they say determine the interquartile range of class B. Interquartile range. What is interquartile range? What is interquartile range? So let's talk about, this is 5.1.5. I'm just gonna say 5.1.5 and say okay, 5.1.5. What is interquartile range? So my recording stopped over there. Sorry about that. We're busy with 5.1.5, which says determine the interquartile range for class B, right? So interquartile range, I've already done it over here. Your interquartile range is Q3 minus Q1. also your upper quartile minus your lower quartile. Q3, remember, is upper quartile and Q1 is lower quartile. So your interquartile range is Q3 minus Q1. And remember, your range, if they just say your range, then it's your maximum value minus your minimum value, right? But if they say interquartile, then it is Q3 minus Q1. Let's go and determine our Q3 and our Q1, right? So if you look at our diagram over here, class B is represented by this box and whisker. And if you remember at the beginning of the video, I said this last line over here on the box represents your upper quartile, also known as Q3, right? So in this case, your Q3 is 70 because this is straight aligned with 70. So your Q3 will be 70. And your Q1, your lower quartile, is represented by this end of the box, like the line on the left of the box, right? And this line is straight aligned with 20, meaning that our lower quartile is 20. Lower quartile is 20. So we can just go and say, okay, upper quartile is 70. We saw on this box and whisker, minimum, not minimum, but the quartile 1, it's 20. So here it is, quartile 1, 20. So it's 70 minus 20, it's 50. Your interquartile range will be 50, right? And then let's go and do 5.1.6. So 5.1.6, they say give the modal percentage mark modal. What is the modal? Modal is the data value that appears more than any other data values. It appears number of times, numerous times more than any other data values. Let me show you what I'm talking about here. I'll just erase here when we were looking for the interquartile range. I just erase this. Remember our F, we found it as 56 if I'm not mistaken. Yeah, here it is 56. So our F is 56. So our modal data will be the amount that appears more times than any other data value. Which one is it? By looking at the data, you can see that it's 66. 66 appears 4 times. There's no other data values that appears 4 times or more than 4 times. 62 only appears 2 times. 75 only appears 3 times, but 66 appears more frequent, more than any other data value, meaning that 66 is your modal data, modal value. So you can just say 5.1.6 and then you say the answer is 66. 66 is your answer. 66 is your answer. That's your modal percentage. So I'll just move to the side a bit, right on that side. So let's do 5.1.7, right? Let's do 5.1.7. So 5.1.7, they say calculate the missing value age. So they need you to calculate age if the mean percentage mark for class A is 70. So the mean, if the mean is 70, calculate age. If the mean is 70, calculate age. What is the mean? Let's start there. What's the mean? The mean, to get the mean, you take the sum of all the data values, meaning that you need to add all these values over here. And after you add all these values over here, you divide them by the total number of learners or the total number of these data values. If you count these data values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Remember, we have 26 learners, so these marks have to be for 26 learners. They have to be 26. So to calculate your mean, you take the sum of the marks. So you add all these marks, say 56 plus 58 plus 60 plus 62, all the way to 90, and then you divide it by the total number of learners. Let me just write the formula down. Let me just write it over here, right? And say, okay, to calculate the mean, what I do is I take the sum of the marks, and then after the sum of the marks I divide it by the total number of learners. So total number of learners, I don't know if I wrote that properly. Yeah, total number of learners. So that's how we calculate the mean, right? Just put it here and draw a line here like this. So the sum of the marks divided by the total number of learners, that's how you get your mean, right? That's how you get your mean. So let's what is the sum of the marks here, right? Meaning that we need to go and add all these marks. Don't forget this 56 we calculated for F, right? So you need to add this 56 as well. So you say 56 plus 58 plus 60 all the way up to 90. But you don't have H over here. So you can't add an alphabet. What you will do is add all the numbers except H and you'll get the sum. So I'll just calculate it. I've already calculated it real quick on my calculator. And then if you add all these values except H, you'll get the answer you get is 1. Let me just say it's 1 7. So this is a 7 and then 4 1, right? That's the answer you get if you add all those numbers, all those marks except H. But I said you have to sum all the marks. You have to sum all the marks of the class, and then after you divide them by the total number of learners. So you don't have to forget that H. You have to put that H here and say, okay, H is still there, right? We need to add H to get the sum of all the marks. But in this case, we just don't know what's the mark of H. And then we divide it by the total number of learners, which is 26, right? And remember in the question, they stated that, okay, the mean is 70%. They stated it here that the mean is 70%. So if you can just go and say mean, you already have 70% this side. You can write 70%, which is your mean, and then you have the sum of all the marks. You added all the numbers except H, and then you say, okay, it's 1741 plus H divided by 26, right? And that's how you calculate your mean, right? So now it's just the matter of solving for your H here. You have to solve for H. How do you do this? First thing first, you need to get rid of all your fraction or all your denominators, right? You need to make sure you get rid of the denominators. How do you do that? If you have a denominator here, you multiply by 26. So when you multiply by 26, this 26 is going to cancel this 26 at the bottom, this 26 which is a denominator. It's going to divide it and then it's going to cancel it. But remember the laws of mathematics. What you do on the left hand side, you must do on the right hand side. And what you do on the right hand side, you must do on the left hand side. So since we multiplied by 26 that side, we need to multiply by 26 this side, right? And if you say 26 times 70, you get 1,820 and equals to, and then this side, since this 26 is cancelled by this 26, you only left with 1741 plus H, right? Simple mathematics. What you do, you take this number 1741 to the other side, and when you take it to the other side, it changes the sign from positive to negative. So you'll have 820 minus 1741 is equal to this H stays this side. And if you minus 1820, if you minus 1741 from 1820, you'll get your H as 79. And this is your value of H. Remember the question we were doing here, it's 5.1.7 when they say determine H if your mean is 70, right? And then we found the value of 79, so we can input it here and say it's 79. Here's the trick I was talking about. So whenever they give you a mean and then they give you data values one with one which is missing, and then they say calculate that value. So what you can do is you can simply say, okay, the missing value, which is H in this case, is equal to, take the mean which they gave you and multiply, they gave us 70 the mean, and multiply it by the number of data values or the number of learners in this case, right, which is 26, and then minus go add all the marks, except age, because you don't have age. Subtract it from this value you get here, and then you remember when you added all those values, you got 171. And you'll see that the answer here for saying 70 times 26, you'll get 1820. And when you minus 1741, you get your value of 79. So you can use this trick if they gave you a mean and then with a set of data values, and then you have one missing. What you can do, you can say that value that's missing is equal to 70 times the number of data values, which is 26 in this case, 26 marks. So you say 70 times 26, and then you minus the sum of all those values you have, except that variable, the age. You add all those ones, and then you subtract it from this one over here. You subtract it from this one, which is 1820, and then you get this 79 over here. We can just go and input 79 real quick over there and say, okay, now we have our age, and our age is 79. Yeah, so we have our age now, and then we can go to 5.1.8. So they say determined as a simplified common fraction the probability of randomly selecting a learner from class A who obtained a mark different. So we're looking for determined as a simplified common fraction. So this probability, we need it as a simplified common fraction, maybe 1 over 1 over 3, 1 over 2, 1 over whatever it can be, of randomly selecting. So if we go to this class and randomly select in class A, if we go to class A and randomly select, what's the probability in fraction form of us selecting a learner who obtained a percentage mark different from any other learner in the class? This basically means the probability of selecting a learner who has his own unique mark, who has their own unique mark which is not the same or as anyone else in the class. So we're looking for those learners with a unique mark, with their unique mark. We can go and count all the learners in class A with unique marks, right? Their own unique mark, which is not the same as any other mark in class, right? And then we can say, okay, 56 is alone, 56 is unique, 58 is also unique too, 60 is unique, 62, you see here 62, we have two learners who got 62. So this mark is not unique since we have two learners who got 62. And 63, it's unique. 65, we have two learners who got 65. So this mark is not of 65, it's not unique. 66, we have four. This mark is not unique. 67 is unique. 69 is unique. 70 is unique. 71 is unique. 73, you have two learners who got 73. Then it's not unique. 75, you have three learners, it's not unique. Don't forget this 79 as well. It's unique. 80 is unique. 83 is unique. 85 is unique, and 90 is unique. And now you go and count all these learners who got unique marks, right? They said probability of randomly selecting in class A learner who got a percentage mark different from any other learner, meaning that a mark that's unique. You go and count all these learners who got unique marks. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 learners got unique marks in this class, right? In class A, 13 learners got unique marks. So if we can go and say, okay, now we're dealing with 5.1.8, right? And say you have 13 learners who got unique marks that are different from any other learner in class. Out of how many learners? Out of 26 learners. So we have 26 learners, but if we go and select the learner at random, we have a chance of selecting out of this 13, all of them got unique marks. So it's 13 over 26. And then to simplify this, you can just punch it in your calculator and say 13 over 26. If you're using a scientific calculator, you will get 1 over 2. And then your 1 over 2 is your simplified probability. So you can just say probability of a unique mark. So this P stands for probability of a unique mark is equal to 13 over 26, which is also 1 over 2. And that's the probability of selecting a learner with a unique mark, right? Let me see if I'm done with the question. Ooh, I'm done. I'm already at 5.1.8, and then we've already collected all these marks over here. And let's see. So we're not done with question 5 though. We still have question 5.2, which deals with more data. But I'm going to record a separate video to discuss this question, the rest of this question. So be sure to check out the next video that's coming up in order to be able to answer these questions. I'll see you on the next video, and please make sure that you like and then comment if you have a question, and subscribe to see more content. See you on the next video. I'm helping you genius up here. Thank you.